Building a home from the ground up begins with what the forest provides. The raw material of a log cabin is found exactly where it will stand. Every tree chosen must be straight, solid, and capable of bearing the immense weight of the future structure. With the initial bark stripped away, the logs must be measured and refined. Precision at this stage dictates the stability of the entire build. A drawknife is used to remove the cambium layer, the thin membrane just beneath the bark. Leaving this layer intact would trap moisture and invite rot or insect damage, weakening the wood over time. Stripping the log down to the bare, light sapwood ensures a clean surface that will dry evenly and shrink predictably as it ages. The sweeping, rhythmic motion of the blade requires both physical endurance and a careful eye to maintain the timber's natural taper without gouging the grain. This is the foundation of traditional log crafting, working with the material's inherent shape rather than forcing it into uniform dimensions. The effort invested now pays off in longevity. The base of the cabin relies on point-load foundations, isolating the wooden structure from the damp earth. Digging down to undisturbed, compact soil prevents the cabin from settling unevenly over the years. Cardboard concrete forms are measured and cut to height, creating uniform molds for the structural pillars. Elevating the floor joists well above the ground allows air to circulate underneath, a simple defense that prevents moisture buildup and keeps the bottom timbers dry across decades of changing seasons. Filling the tubular forms with wet concrete anchors the cabin firmly to the site. A single metal rebar rod is set into the center of each pier while the mix is still malleable. Once the concrete cures, this heavy steel pin will interlock directly with the base logs, preventing any horizontal shifting during high winds or gradual ground movement. The concrete hardens through a chemical reaction, creating a dense, weather-resistant footing that will outlast the builders. This solid, immovable connection between earth and wood is the critical prerequisite before the first structural timbers can be laid. The joinery is where heavy timber becomes architecture. A hammer and chisel are used to carve out precise saddle notches, locking the intersecting logs together. The goal is to create a cup-like depression that perfectly mirrors the contour of the log resting beneath it. When done correctly, the weight of the structure pulls the joints tighter together over time as the wood shrinks and settles. Sharp tools are essential here. A dull blade will crush the wood fibers rather than cleanly severing them, leading to jagged edges that invite water pooling and decay. The rhythmic sound of steel on wood marks the slow, deliberate pace of hand-hewn construction. Each notch is a unique puzzle piece, custom fitted to the specific irregularities of the timber. There is no mass production here, only the careful translation of raw forest into shelter. With the initial joints prepared, the base logs are hoisted onto the concrete piers. A transfer scribe is used to map the exact topography of the lower log onto the upper one. This tool keeps a parallel distance, tracing the curves and bumps so they can be perfectly replicated in the notch. The tighter the initial fit, the less cold air and moisture can penetrate the walls once the cabin is sealed. It is a slow, methodical process of measure, cut, and test. Refining the fit often requires multiple adjustments. An axe quickly removes bulk material, while finer tools clean up the contact points. The logs must settle into each other without rocking or binding. This friction-fit joinery relies entirely on gravity and precise angles to hold the corners square, eliminating the need for complex metal fasteners that might rust or fail. To further stabilize the vertical alignment, wooden pegs, often called trunnels, are driven into pre-drilled holes. These hardwood pegs shrink at a different rate than the surrounding softwood logs, effectively locking the massive timbers in place as the entire structure dries and settles. This ancient fastening technique allows the walls to flex slightly under extreme wind or heavy snow loads without snapping. It distributes the mechanical stress evenly throughout the wooden frame, rather than concentrating it at rigid metal joints. As the walls rise, the physical toll increases. Every log must be lifted, positioned, and often removed again for further refinement. The notches are continuously checked to ensure the corners remain plumb and the walls grow straight. Even a millimeter of error at the bottom will compound into inches by the time the roof is reached. The wooden pegs continue to pin the courses together, creating a monolithic structure out of individual trees. The heavy lifting is balanced by the delicate, precise chisel work required to maintain the structural geometry. It is a constant negotiation between the raw weight of the timber and the exactness of the builder's vision. Deep, rectangular notches require aggressive chisel work, clearing out significant waste wood to create strong, interlocking corners. A long drawknife makes quick work of peeling the remaining logs, preparing them for the stack. The laser level brings modern precision to the ancient craft, ensuring the horizontal lines remain true, as the terrain and timber vary. Removing the outer layers reveals the dense structural core of the wood, ready to bear the load of the roof. The higher the walls grow, the more demanding the assembly becomes. Lifting hundreds of pounds of raw timber requires coordinated leverage and raw strength. Heavy metal spikes are occasionally driven into the top of the logs to anchor specific load-bearing sections, supplementing the wooden joinery. The floor frame lays out the footprint of the living space, a grid of parallels logs that will support the decking. Each newly carved notch must be flawless. A clean cut minimizes gaps and maximizes the wood-to-wood contact area, which is vital for both insulation and structural rigidity. The interlocking corners are the strongest part of a log cabin, binding the four walls into a single, cohesive unit capable of withstanding the elements. A heavy sledgehammer drives long metal spikes deep into the timber. This mechanical fastening provides immediate shear strength, preventing the logs from twisting or bowing outward as they cure. Wood is a dynamic material. It will continue to move, expand, and contract with changes in humidity. Pinning the courses together ensures the walls remain stable, while the natural drying process takes its course over the next several years. The final top logs, known as the plates, tie the upper walls together and provide the foundation for the roof. Securing these massive timbers locks the square shape of the cabin. With the perimeter established, the focus shifts upward as hand saws make the initial cuts for the complex roof framing. Before the roof closes in the structure, the rough openings for doors and windows must be established. A solid wooden door frame is fitted into the log wall, hammered into place to create a rigid boundary. This frame, or buck, allows the horizontal logs to settle independently without crushing the door itself. As the cabin shrinks vertically over time, the logs will slide down around the door frame. If the door were attached directly to the logs, the immense weight of the settling roof would eventually bow the jambs and shatter the glass. Proper framing ensures the home remains functional long after the wood has dried. Pushing the gable ends higher requires lifting timber well above chest height. The logs are shorter here, tapering inward to follow the slope of the future roof. Each piece is notched and stacked with the same precision as the base layers, forming the triangular peak that will support the central ridge beam. The higher they build, the less room there is for leverage, making every placement a test of balance and endurance. As the walls reach their maximum height, the final structural framing is locked into place. Chisel work at this elevation is awkward but critical. The top surfaces must be perfectly flush to receive the heavy roof components. Wooden frames are set into the wall openings, providing structural breaks that must be carefully bridged and reinforced to maintain the cabin's overall integrity. These upper courses of logs carry the heaviest burden of the entire build. They must transfer the massive downward force of the roof framing, the exterior panels, and eventually the crushing weight of winter snow, evenly down through the walls to the concrete foundation. Every tight joint and driven peg ensures that weight is managed safely. Heavy wooden bracing is hammered into the upper frame to stabilize the gables before the ridge beam is lifted. Protective face shields defend against flying wood splinters and metal shavings. This temporary bracing acts as a rigid scaffold, holding the steep triangular walls perfectly plumb while the heavy lifting of the roof assembly begins. The central ridge beam is the spine of the roof. It must sit perfectly level across the apex of the cabin. The metal transfer scribe traces the irregular grain of the lower support log onto the ridge beam, ensuring a seamless, gap-free connection. This meticulous scribing is what allows round, unmilled logs to function as precision structural elements. A drawknife shapes the beam to the exact marked line, shaving away the excess wood until the two massive timbers nest together flawlessly, ready to bear the outward thrust of the rafters. The top plate logs run parallel to the ridge beam, firmly capping the side walls. Straddling the high timber, a builder drives a thick wooden peg deep into the joint with a heavy mallet. This pin locks the plate directly to the vertical posts, preventing the horizontal thrust of the roof from pushing the walls outward. In traditional timber framing, this connection is vital to the structure's survival. If the top plate shifts or fails, the massive weight of the roof will flatten the building. The deep wooden pegs provide the necessary tensile strength, turning separate, stacked logs into an unbreakable structural perimeter. Lifting the heavy timber to the peak is a test of raw physical strength and careful coordination. Working high above the ground, the builders must balance on the narrow top walls to guide the ridge logs into place. Gravity is no longer just a tool for settling joints. It is a constant, dangerous force pulling against their efforts. Securing the apex timber completes the primary structural triangle, locking the gables together and defining the final slope of the roof. With the central ridge and wall plates securely set, the heavy rafters can be installed. Deep, angled notches must be carved directly into the roof logs to cradle the rafter beams. The sharp chisel shears cleanly through the wood grain, creating flat, stable-bearing surfaces on the otherwise round logs. This precise joinery prevents the rafters from sliding down the steep's slope under their own weight. The exact angle of these cuts dictates the pitch of the roof, a critical calculation that balances comfortable interior headroom with the steepness required to shed heavy winter snow. The mallet drives the steel edge deep into the timber, hollowing out the structural pockets that will carry the entire canopy. Creating these deep structural joints is a sustained exercise in patience and physical endurance. The builder must continuously carve and clear the waste wood, frequently checking the depth and angle against the specific rafter profile. An imperfect, shallow notch creates a dangerous point load, forcing the entire weight of the roof onto a small sliver of wood, which can easily split under pressure. A flush, full contact joint distributes the immense load evenly across the timber's grain, maximizing its natural compressive strength. This invisible layer of careful craftsmanship is exactly what keeps the heavy roof standing firm during violent mountain storms and deep winter snowfalls. The crucial transition from raw, heavy timber to processed materials begins with the roof sheathing. Thick plywood sheets are laid across the lower rafters, tying the individual wooden beams into a rigid, unified diaphragm. This continuous flat surface prevents the rafters from twisting or swaying side to side, adding immense shear strength to the overall cabin frame. The solid decking also provides a smooth, stable substrate for the waterproof filaments and metal panels. Even as modern sheets are nailed down, bringing long logs from the forest remains necessary to brace the interior structure. It is a reminder that the cabin is a hybrid of ancient timber framing and modern building materials. The sheathing turns an open skeleton into a closed shelter, defining the boundary between indoors and out. Working exposed on an open roof frame is a precarious, high-altitude balancing act. The builder must carefully navigate the narrow, sloped timber logs to position and secure the higher sheathing panels. Every swing of the hammer requires solid footing and absolute focus to avoid a dangerous fall. Securing the boards at this elevation locks the upper rafters together tightly, reinforcing the steep pitch. The higher the wooden sheets go, the more difficult the maneuvering becomes, as the sharp angle offers little traction for work boots. The plywood acts as a massive shield, bracing the tall gables and transferring wind loads smoothly across the entire roof plane, ensuring the structure can resist the unpredictable forces of the open forest. Standing directly on the skeletal frame, the builder hammers the final connections near the peak. The chisel is used one last time to refine a stubborn joint, proving that even at the highest point, precision cannot be compromised. The ridge is the most critical junction of the roof, where opposing forces meet and must be perfectly balanced to prevent structural failure. A final inspection of the carved joints confirms that the load is distributing properly before the rest of the roof is enclosed. The builder straddles the central ridge beam, the literal high point of the cabin, to hammer the upper rafters into their notches. The ridge beam acts as the anchor point, resisting the downward pull of gravity on the sloped sides. By securing the rafters directly to this central spine, the weight is channeled outward and downward, pushing the walls firmly into the earth. The woman holding the lower end of the timber ensures it stays aligned with the floor joists below, maintaining the structural grid. This high-altitude carpentry locks the skeleton of the roof together, transforming a collection of heavy logs into a self-supporting geometric arch that can defy the weather. Lifting the massive horizontal purlins onto the steep roof frame requires perfect timing and teamwork. The man on the roof carefully guides the heavy log into its carved notch while the woman pushes upward from the platform, fighting gravity. These horizontal beams run perpendicular to the main rafters, adding crucial mid-span support to the long, sloping roof. They prevent the long rafters from bowing inward, from bowing under heavy loads, breaking up the wide span and adding immense structural rigidity to the wooden canopy. The final long logs are carefully maneuvered into position, closing out the dense wooden grid of the roof. This intersecting network of heavy rafters and horizontal purlins creates a massive web of strength engineered to support thousands of pounds of dense winter snow. The interlocking timbers share the mechanical burden, ensuring that no single joint has to bear the full force of the elements alone. With the complex skeletal canopy finally complete, the high structure is prepared to be fully sheathed, transforming the open log grid into a solid, impenetrable surface against the sky. By afternoon, the angle of the fully sheathed roof makes free climbing too dangerous. A climbing harness and safety rope are secured, allowing the builder to lean back against the steep pitch and work with both hands. Hammering nails into the plywood decking locks the roof diaphragm down tight to the purlins. From the inside, additional nails are driven up into the rafters to reinforce the connection. Every nail increases the shear strength of the roof, ensuring the wide, flat panels cannot be torn away by the powerful updrafts that sweep through the forest during a storm. Sitting high on the roof peak, the builder drives the final structural nails into the upper sheathing, completely closing the wooden envelope of the cabin. This continuous layer of thick plywood creates a rigid exterior shell, essential for stabilizing the tall, wind-battered gable walls. Back on the ground, a hand plane is used to carefully smooth the rough edges of an interior wall log, returning focus to the finer details of the build. The sharp steel blade cleanly shears away the torn wood fibers, leaving a smooth, sealed surface that naturally repels moisture far better than a rough sawn edge. This constant transition between heavy structural engineering and delicate hand finishing defines the demanding dual nature of traditional log cabin construction. The raw wood must be protected immediately. A blue synthetic waterproof membrane is rolled out and secured over the plywood decking. This underlayment tension serves as the last line of defense, catching any condensation or wind-driven rain that might slip past the metal roofing. Working in a harness, the builder locks the membrane down tight, ensuring it won't flap or tear in the wind. The overlapping seams create an unbroken barrier, shedding water downward and keeping the structural timber completely dry. The green corrugated metal roofing panels offer long-term durability and protection against the harsh forest climate. The ridge design provides immense vertical strength, allowing the relatively thin metal sheets to span the gaps across the roof deck without sagging under the crushing weight of snow. The first panel must be aligned perfectly square to the edge of the roof. Any slight deviation here will compound across the entire span, resulting in a crooked and compromised roofline. Hammering the initial fasteners locks the steel firmly in place, while smoothing the blue underlayment ensures there are no hidden wrinkles that could trap moisture beneath the metal. This rugged outer armor permanently shields the vulnerable wooden skeleton underneath. Transporting the massive steel roofing panels through the dense, uneven woods is a constant exercise in careful navigation. The thin metal edges are unforgivingly sharp, and the long, flexible sheets catch the breeze easily. Maneuvering them safely up to the high roofline without bending, scratching, or creasing. The metal requires synchronized, coordinated effort. Once squared into position, specialized roofing screws fitted with thick rubber washers are driven deeply through the metal into the solid wooden deck below. The rubber gasket compresses tightly, permanently sealing the drilled hole against water intrusion. Driving the screws through the raised ridges rather than the flat valleys ensures that flowing rainwater naturally bypasses the penetration points, vastly minimizing the risk of hidden leaks as the seasons change. Reaching the upper sections of the steep roof requires placing a wooden ladder directly onto the slippery angled metal panels. The overlapping seams of the corrugated sheets are designed to lock together, creating a continuous, watertight channel from the high ridge down to the eaves. Adjusting the heavy panels high on the pitch is dangerous, exacting work. The builder must ensure the overlap is tight and perfectly parallel before driving the final ceiling screws. A poorly seated, gaping seam will easily allow high winds to drive rain uphill and under the metal, eventually rotting the wooden deck hidden below. Custom cuts are inevitable, especially around the roof edges. Metal snips shear through the rigid steel, allowing the builder to tailor the panel to the exact dimensions of the gable. Cutting metal by hand is slow and taxing, but it prevents the heat damage and rust issues caused by abrasive power saws, preserving the factory coating on the steel. Positioning a heavy wooden extension ladder against the log walls provides necessary access to the highest peaks of the gables. The thick metal trim pieces must be custom cut to fit the complex, intersecting angles of the roofline. Heavy-duty, red-handled snips bite forcefully through the steel, a physically demanding task that requires significant hand strength and patience. These trim pieces serve as crucial armor for the exposed edges of the wooden roof deck. They neatly cap the vulnerable plywood sides, preventing wind-driven rain and snowmelt from soaking into the porous end grain of the wood. Carrying these long, awkward metal strips up the tall ladder requires intense balance and care, as a sudden gust of wind could easily throw the builder off the rungs. Properly installed edge trim not only gives the cabin's roof a finished, sharp look, but it acts as a rigid windbreak, stopping powerful storms from getting under the main roofing panels and tearing them upward. The absolute peak of the roof is inherently the most vulnerable point for water entry. A thick, continuous bead of weather-resistant sealant is applied beneath the final ridge cap, creating an impermeable, rubberized gasket along the apex. The power drill drives the heavy screws through the metal trim, forcefully compressing the sealant down into every gap and contour of the corrugated panels. Capping the high ridge effectively completes the exterior shell of the roof, finally making the cabin fully watertight from above and fully prepared to face the heavy, impending winter snows. With the overhead exterior sealed, the focus shifts inward to trapping heat. Rigid foam insulation board is precisely cut to size, designed to fit tightly into the bays between the heavy wooden floor joists. Crawling into the dark, cramped subfloor is an uncomfortable, dusty necessity. The thick foam panels create a vital thermal break between the freezing ground below and the interior living space above. Without this hidden layer of insulation, the raw wooden floor would radiate cold continuously, drawing warmth out of the cabin far faster than any fire could replace it. Pressing the rigid boards firmly into place physically blocks the bitter drafts that sweep under the elevated structure, ensuring the foundation acts as a stubborn barrier to the winter freeze rather than a conduit for it. To further protect the cabin interior from rising dampness, a continuous plastic vapor barrier is tightly stapled over the insulated floor joists. This impermeable membrane blocks ground moisture from evaporating into the living space and prevents warm, moist interior air from condensing inside the cold floor cavity. A hidden danger that leads directly to mold and structural rot. Heavy, composite floor sheathing is then carefully laid over the red barrier. Drilling these thick, dense panels directly into the log joists creates a rigid, unified floor diaphragm. This solid decking locks the lower half of the cabin together, providing a flat, unyielding surface that will soon support the immense, concentrated weight of the stone hearth and the heavy cast-iron stove. The beating heart of any off-grid cabin is its central heat source. Muscling the heavy black cast-iron stove into the small room is a brutal test of raw strength, requiring careful leverage and coordination to avoid damaging the newly laid floor. For the protective hearth, natural flat stones are gathered directly from the surrounding woods. Using local, unrefined stone visually anchors the interior design to the rugged landscape outside. Through the rough, unfinished window opening, the changing autumn forest provides a vivid, silent reminder of the rapidly closing weather window. The heavy stove must be fully installed and operational before the deep winter freeze sets in, making the completion of the fireproof hearth the most urgent priority.
Forward. Yeah.
Wood floors and hot cast-iron stoves are a dangerous combination. Without proper thermal shielding, thick cement board is laid down securely in the corner, providing an absolutely fireproof, non-combustible base layer that will not warp, crack, or burn under intense radiant heat. Hot, dry, heavy gray mortar mix is poured into a bucket, ready to be hydrated. This specialized, heat-resistant cement will bind the gathered river stones together, creating a massive thermal sink. This stone mass absorbs the stove's fierce heat during the day and radiates it slowly, steadily back into the room long after the fire dies down at night. Building the rustic hearth requires a careful mason's touch. Thick, heavy gray mortar is troweled deeply into the irregular gaps between the flat fieldstones, locking them into a solid, immovable pad. The wet mortar must be packed tightly to completely eliminate any hidden air pockets, which could violently expand and crack the masonry when subjected to extreme temperature shifts from the fire. Once the stone and cement base cures into a monolithic, fireproof slab, the heavy cast-iron stove is carefully maneuvered into its final resting place. Sitting proudly elevated on the natural rock, the stove is now permanently isolated from the combustible wooden structures surrounding it, ready to safely contain the intense fire that will make the cabin habitable through the deep winter. Closing in the high upper gable ends requires a transition from heavy, stacked logs to lighter, flat wooden planks. The large triangular space beneath the sloped roofline is framed out and securely clad in vertical boards. Hammering these planks into place completely seals the massive opening that would otherwise let the bitter winter winds howl right through the attic space. Aligning the straight boards perfectly over the uneven, rustic log frame requires constant measuring and careful adjustment, ensuring a tight, draft-free seal against the weather. This much lighter framing method also significantly reduces the crushing, unnecessary weight bearing down on the highest, most unsupported span of the cabin walls. Working at the very peak of the gable means constantly climbing up and down the wooden ladder while carrying awkward, wide boards. Each plank must be measured in place directly against the sloping roof rafters, then brought back down to be cut precisely to the correct angle with a handsaw. The sharp diagonal cuts must match the pitch of the metal roof perfectly, leaving absolutely no gaps for driving rain or fine snow to penetrate the interior. The slow, methodical rhythm of measure, climb, cut, and fit gradually but surely encloses the final open airspace of the wooden home. By late afternoon, a heavy wooden frame is constructed specifically to house the upper gable window. Sitting high on the exposed interior beams, the builders muscle the square unit securely into the triangular wall. This upper window is crucial for the home's airflow. It will vent trapped, stagnant heat in the summer and pull in essential natural light to illuminate the dark attic loft, effectively turning a cramped overhead storage space into a functional, breathable room. Deliberately penetrating a perfectly waterproof roof to install a chimney is a high-stakes, nerve-wracking operation. The flat metal flashing must be secured tightly to the angled, green corrugated panels, creating an immediate water-shedding barrier around the vertical pipe. Heavy screws lock the wide metal base down, biting deeply into the solid wooden decking below. The metal flashing is engineered to flex slightly with the rapid expansion and contraction of the hot chimney pipe without ever breaking its waterproof seal. Lowering the heavy, double-walled, stainless steel chimney through the tight hole requires absolute precision. The pipe must remain perfectly plumb to draw the dangerous smoke efficiently up and safely away from the cabin. The flexible rubber boot is the final, absolutely critical defense against disastrous roof leaks. A thick, unbroken bead of clear silicone sealant is injected heavily under the flange, filling any microscopic voids between the rubber and the steel metal flashing. The drill then forcefully drives screws through the outer edge, permanently compressing the silicone gasket flat. This specialized rubber cone grips the hot chimney pipe tightly, safely expanding and contracting with the extreme temperature swings of the roaring fire, while efficiently shedding rainwater down the steep slope. If this single vital seal fails, water will run directly down the pipe and quickly ruin the steel stove below. Perched precariously on the steep, slippery metal roof, The builder lifts the tall, awkward section of stainless steel pipe straight into the biting wind, locking it firmly into the base with a heavy metal band clamp, secures the towering flue against heavy, unpredictable gusts. The tall, insulated chimney creates the necessary, powerful updraft. It utilizes the sharp pressure difference between the extremely hot firebox inside and the freezing cold outside air to actively pull the toxic smoke up and safely out of the cabin. Inside the cabin, the black single-wall interior stovepipe is carefully connected to the insulated ceiling box. The sliding metal joint must be aligned perfectly and seated deeply to prevent deadly carbon monoxide gas from ever leaking into the enclosed living space. With the mechanical heating system securely finished, attention turns back to the natural aesthetics of the room. Wandering down to the icy, flowing forest stream, the builder searches for flat, smooth stones to finish the decorative hearth surround. The frigid water has tumbled and polished these heavy rocks for centuries, slowly softening their sharp edges. Bringing the cold riverbed inside not only visually grounds the cabin in its specific location, but adds massive, fireproof thermal weight immediately around the stove, ready to capture and store every degree of radiant heat possible. Troweling thick, heavy mortar deeply between the gathered river stones finally completes the thermal battery of the hearth. The wet cement binds the loose rocks into a single, massive, immovable heat sink. As the mortar is carefully smoothed and the excess wiped away with a damp sponge, the true, dark, vibrant colors of the wet stone brilliantly emerge. This meticulous, patient masonry work transforms a raw, scattered pile of rocks into a polished, highly functional architectural feature. The finished hearth is designed to absorb the fierce, immediate energy of the fire, slowly and steadily releasing that safely stored warmth back into the cabin throughout the freezing, sunless winter nights. Installing a rigid window into a settling log wall requires careful, simultaneous coordination from both sides of the glass. While the heavy frame is leveled and secured from the inside, a pry bar makes critical micro-adjustments on the exterior to ensure the unit sits perfectly square and plumb. Any twisting or warping will eventually crack the glass as the heavy logs dry and settle. Once properly locked in, yellow fiberglass insulation is packed tightly into the rough, uneven gaps around the frame. This fibrous material traps dead air, completely stopping freezing cold drafts from bleeding through the wall cavity while still allowing the heavy logs to shift and compress slightly over time without crushing the delicate window frame. Preparing the solid, heavy door frame requires precise, careful carpentry. The builder drills necessary pilot holes before driving the long screws, a crucial step that prevents the dry, light-colored pine from instantly splitting under the extreme torque of the drill. The heavy wooden jambs must be assembled perfectly straight and rigidly to safely hold the massive swinging weight of a solid timber door. If the frame is built skewed or compromised in any way, the heavy door will inevitably sag and fail to latch, completely destroying the vital airtight seal of the heated cabin. A razor-sharp chisel carefully hollows out shallow, precise mortises in the wooden frame to perfectly recess the heavy metal door hinges. Removing just enough wood allows the steel hinge plates to sit perfectly flush with the surface, ensuring the solid door closes tightly against the jamb without binding or catching. Standing squarely in the entryway, the builder firmly adjusts the massive frame, anticipating the heavy daily foot traffic, the changing seasons, and the hard slamming that this critical threshold will endure for decades to come. The traditional hand plane is the ultimate tool for refining raw, rough-sawn lumber. With each smooth, forceful pass, the sharp iron blade cleanly shaves a micro-thin curl of wood from the board, quickly leveling high spots and revealing the beautiful, tight grain beneath. This purely manual surfacing process leaves a glass-smooth, burnished finish that modern sandpaper simply cannot replicate. It effectively closes the pores of the wood, preparing the trimmed boards to endure the heavy wear and tear of daily life inside the small cabin. Up in the dark, cramped attic loft, the hand plane is used once again to carefully smooth the rough edges of the pine floorboards. Working surrounded by the thick, itchy pink fiberglass insulation, the builders precisely fit the long, flat boards directly against the angled wooden roof frame. Creating a solid, finished floor in the loft completely transforms the previously unused overhead cavity into a warm, insulated sleeping area. This high space efficiently captures and holds the radiant heat that naturally rises from the cast iron wood stove directly below. The harsh, unforgiving reality of deep winter construction occasionally forces the difficult work outside into the heavy snow. Planing a nearly frozen pine board requires significant extra physical effort, as the icy, stiff wood stubbornly resists the sharp steel blade. The bitter, biting cold of the exterior forest starkly contrasts with the warm, tightly sealed environment they are frantically trying to finish inside. Every single board painfully prepped out in the freezing air brings the builders one critical step closer to retreating and remaining permanently indoors. Kneeling on the hard, unyielding subfloor, the builder carefully positions the long, newly smoothed pine boards and nails them securely down into the heavy log joists. The final installation of the finished wooden flooring completely transforms the interior space from a dusty, rugged construction site into a refined, truly livable home. The tight, flawless seams between the long boards effectively lock out freezing drafts from below and provide a warm, exceptionally durable surface underfoot. Sealing the exterior envelope of the cabin is a constant race against the worsening elements. Hammering the thick, heavy wooden trim pieces tightly around the outside of the window frame serves a crucial dual purpose. Aesthetically, it beautifully frames the glass and completely hides the rough, uneven gaps packed with yellow insulation. Structurally, it acts as an absolutely critical weather break, permanently shielding the vulnerable seams from driving winter snow and freezing rain. If moisture penetrates the tiny gaps around the window, it will freeze, expand violently, and slowly push the frame apart, completely compromising the cabin's airtight seal. Nailing the thick trim boards tightly against the uneven log wall closes off the wall cavity permanently, locking the brutal weather outside where it belongs. High up on the unsteady ladder, the final thick wooden trim is hammered securely into the steep roofline, permanently sealing the dangerous gap between the corrugated metal roof and the upper log walls. Trudging back and forth through the deep, heavy snow to carry the very last boards is exhausting, bone-chilling work, severely testing the builder's physical endurance. Every single piece of exterior trim successfully installed is another vital layer of armor against the brutal cold, ensuring the small cabin can withstand the punishing weight and freezing moisture of the surrounding winter. To properly and safely vent the sealed structure, a perfect circle must be cut directly through the rigid green metal flashing. A powerful drill equipped with a specialized hardened hole saw attachment bites forcefully through the steel, throwing small sparks and sharp metal shavings. This incredibly precise, clean cut allows for essential airflow components that prevent warm moisture buildup inside the tightly sealed roof cavity, actively protecting the hidden timber from unseen, destructive rot. With the main cabin completely sealed and secured, demanding work immediately begins on the outdoor porch extension. Carving deep, precise notches into raw, massive logs with a heavy mallet and sharp chisel establishes the unyielding framework for the new addition. The exposed joinery here must be just as robust as the main structure, as the open porch will bear the full brunt of the wind and heavy snow loads deflecting off the face of the cabin. Carrying the heavy, freshly peeled timber toward the front of the home clearly signals the final phase of major structural framing, boldly expanding the cabin's footprint out into the forest. Heaving the long, incredibly heavy log beam high onto the vertical support posts requires maximum physical exertion and perfect balance. A bright yellow ratchet strap is quickly wrapped tightly around the timber, temporarily locking the massive, precarious piece safely in place while it is permanently fastened with heavy hardware. This long horizontal beam forms the solid outer boundary of the porch roof, an absolutely critical load-bearing element that must support the heavy rafters suspended over the wide, open expanse.
Ready?
Yeah.
On. Let me know when you're ready.
Ready?
Okay, we're in.
Standing precariously on the partially finished, open porch floor, the builders muscle another long, heavy, horizontal log across the wide span. Positioning these massive roof beams ties the outer porch structure directly back into the solid main log wall of the cabin itself. The new porch relies entirely on the immense shear strength of these deep connections. If the long beams ever sag or pull away from the wall, the entire addition could easily collapse under the crushing weight of a sudden heavy winter snowstorm. The solid vertical wooden walls provide a vital windbreak, partially enclosing the exposed space. Securing a heavy, dark tarp tightly over the porch roof frame offers immediate, temporary protection from the falling snow, while the tedious interior work continues. Hammering the final wooden planks to frame the tight enclosure effectively transforms the open deck into a highly sheltered transition zone. This crucial intermediate space allows the tired builders to shed their wet, snowy gear before ever entering the main cabin, keeping the beautifully finished living area completely dry and clean. Installing the rigid black rectangular frames around the large wall openings permanently turns the covered deck into a true screened-in porch. The incredibly tight mesh will soon block the relentless swarms of summer insects, while still allowing the cool forest breeze to flow freely inside. Securing the heavy frames firmly against the rough wood ensures the protective barrier is absolutely impenetrable, easily making the porch a comfortable, highly livable room long after the deep winter snow finally melts. Custom, precision woodwork seamlessly integrates the new porch additions with the raw, structural logs. A sharp metal scribing tool is carefully used to exactly trace the highly uneven contour of a vertical support post directly onto a flat wooden board. This ancient, reliable technique allows straight, factory-milled lumber to fit absolutely perfectly against the wildly irregular shapes of natural timber. Once accurately cut, the curved notch of the custom shelf hugs the round log flawlessly, leaving absolutely no gaps. It is a small, quiet, hidden detail, but it perfectly exemplifies the immense patience and exact precision constantly required to build harmoniously with wild, unmilled wood. A sharp hand plane smooths the very final board, quietly putting an end to the heavy, exhausting carpentry. The finished porch is a stunning revelation, a fully paneled, tightly screened-in sanctuary perfectly bridging the gap between the wild forest and the warm cabin interior. The light screen door clicks shut, firmly sealing the safe space. As the deep winter snow finally melts and the surrounding forest explodes into vibrant, lush green leaves, the temporary tarp is finally removed. Standing high on the new porch roof, the builder hauls up the permanent, heavy green metal roofing panels. Carefully smoothing out the blue synthetic underlayment guarantees a flawless, waterproof seal. Lifting the long, awkward metal sheets into position and driving the final locking screws completely finishes the ultimate defensive layer of the home. The rugged metal roof now covers the entire footprint, unifying the original log structure and the new wooden addition under a single, impenetrable shield against the open sky. Even the tightest, most expertly carved log joints will eventually shift, shrink, and open slightly as the massive timbers continue to dry over the coming years. To permanently seal the walls against the elements, the wide gaps between the logs must be properly chinked. A gloved hand forcefully presses long strips of flexible metal mesh deep into the dark horizontal voids. This tough wire backing provides a solid, gripping physical structure for the wet mortar to grab onto, effectively preventing it from cracking and falling out. As the natural wood continuously expands and contracts with the changing seasons, pushing the metal mesh deeply into the crevice ensures the final heavy layer of chinking sits flush with the logs, creating a smooth, absolutely weatherproof barrier that completely stops the biting wind. A trowel expertly smooths the thick gray mortar over the wire mesh, tightly sealing the horizontal seams. The chinking cures into a hard, durable barrier, locking the massive logs into a single, airtight fortress. This final, tedious layer of weatherproofing marks the end of the long journey. From a raw, snowy clearing, an independent home has emerged. Solar panels now silently harvest power on the green metal roof, while rain barrels collect fresh water from the eaves. A small garden takes root in the cleared earth. The structure now provides everything it needs to sustain life off the grid. In the end, the architecture and the surrounding landscape operate as one cohesive system, a quiet, enduring place that produces, protects, and sustains itself.